All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Something is wrong. We may have to revise our theory of the creation of the universe. A quantum AI system processing decades of Voyager data has detected something truly alarming in an image from Voyager 1. This discovery is so profound that it challenges our most fundamental understanding of reality. This isn't just another glitch or sensor malfunction from aging equipment. What this advanced AI detected challenges our fundamental understanding of physics, space, and possibly our place in the universe itself. But what exactly did it find, and what does it mean for the future of space exploration? Why has this discovery been kept from the public eye until now? The implications reach far beyond astronomy, touching on questions that have haunted humanity since we first gazed at the stars and wondered if we are alone. The discovery came when NASA scientists decided to reprocess Voyager 1's historical data using a new quantum AI system designed to detect patterns invisible to conventional analysis methods. This AI, developed as part of a classified project to search for subtle anomalies in deep space data, employs quantum computing techniques that allow it to perceive correlations and patterns that would remain invisible to traditional computing systems. The results were unsettling. In a series of images taken as Voyager 1 crossed the heliosphere boundary, the edge of our sun's influence, the AI detected an anomalous structure that appeared to shift position between frames in ways that defied conventional physics. These images, captured by Voyager's aging cameras between 2012 and 2015, showed nothing unusual to human analysts when they were first received. But the quantum AI, looking deeper into the data layers, found something extraordinary. The anomaly appears as a faint geometric structure, almost like a lattice or grid, visible only when the quantum AI enhanced and compared multiple image frames using advanced pattern recognition algorithms. The structure exhibits a level of order and complexity that appears statistically impossible to occur naturally in space. What makes this truly bizarre is that this structure seems to exist in a fixed position relative to Voyager itself, regardless of the probe's movement through space. In other words, it's as if Voyager 1 is carrying something with it or something is following it. Initial analysis ruled out sensor artifacts, data corruption, or transmission errors. The structure consistently appears in multiple datasets from different instruments, confirming its presence as a real phenomenon rather than a technical glitch. Is this just a subtle artifact of aging equipment billions of miles from home? Or could it be something much more significant? Something that fundamentally challenges our understanding of interstellar space. The scientists involved began to question everything they thought they knew about the physics of deep space. If this kind of mind-blowing science excites you, make sure to subscribe. We dive into discoveries like this every week. Hit that notification bell too, because what you're about to hear gets even stranger than you might imagine. The story of what Voyager has potentially discovered could change our understanding of the universe forever. To understand the full significance of this discovery, we need to appreciate just what Voyager 1 is and why it matters. Launched on September 5, 1977, Voyager 1 is humanity's most distant explorer, a one-ton spacecraft now traveling at about 38,000 miles per hour through interstellar space. When it left Earth, Jimmy Carter was president, the first Star Wars movie had just been released, and the internet didn't exist. Its primary mission was ambitious but relatively straightforward: to study Jupiter and Saturn, taking advantage of a rare planetary alignment that occurs only once every 176 years. After giving us our first detailed views of Jupiter and Saturn in the late 1970s and early 80s, Voyager 1 continued outward, eventually crossing the helipause in 2012, becoming the first human-made object to enter interstellar space. This humble spacecraft carries instruments designed in the 1970s that are somehow still functioning, powered by radioisotope thermoelectric generators that convert heat from the decay of plutonium into electricity. It's a technological miracle that we're still receiving any data at all from something so distant and so old. The signal Voyager sends back is incredibly faint, about 20 billion times weaker than the power needed for a digital wristwatch. What's even more remarkable is that Voyager 1 carries the famous golden record, a time capsule of Earth sounds, music, greetings, and images intended for any intelligent extraterrestrial life that might find it someday. This 12-inch gold-plated copper disc contains everything from Bach to Chuck Berry, whale songs to human laughter, and greetings in 55 languages. It represents humanity's first deliberate message to the cosmos, a bottled note cast into the vast cosmic ocean. The spacecraft has enough power to maintain communications until approximately 2025, after which it will continue its silent journey among the stars, potentially outlasting human civilization itself. In about 40,000 years, it will pass within 1.6 light-years of the star Gliese 445. It's against this backdrop, a 46-year-old spacecraft carrying a message to the stars, that our quantum AI made its disturbing discovery. A technological relic from the disco era may have stumbled upon something that our most sophisticated modern observatories have missed. So what exactly is the structure that appears in the enhanced images? The leading theory from NASA scientists is surprising but grounded in emerging physics. The structure detected by the AI bears a striking resemblance to theoretical models of quantum foam, the microscopic fluctuations in spacetime itself predicted by quantum gravity theories. Essentially, at the smallest scales, spacetime isn't smooth but bubbling with tiny wormholes and dimensional fluctuations, like the surface of a glass of soda. At microscopic scales, quantum foam was first proposed by physicist John Wheeler in 1955, who described spacetime as foamy due to quantum fluctuations. These fluctuations are thought to create microscopic wormholes, black holes, and other exotic structures that constantly appear and disappear, creating a dynamic, ever-changing geometric landscape at the quantum level. The problem? Quantum foam should exist at the Planck length, about 10 to the power of -35 meters, far smaller than anything we could possibly observe with current technology. To put this in perspective, if an atom were enlarged to the size of the entire observable universe, the Planck length would still be smaller than a tree on Earth. Yet here it is, apparently visible in Voyager 1's images when enhanced by quantum AI. One NASA physicist, Dr. Elena Reyes, proposed that what we're seeing might be a macroquantum effect, a phenomenon where quantum behaviors manifest at larger scales under certain conditions. The interstellar medium beyond our solar system might create these conditions in ways we never anticipated. The boundary between our solar system and interstellar space might be more than just a transition in particle density and magnetic fields. It could be a region where the fundamental rules of physics themselves begin to shift. Dr. Reyes theorizes that the vacuum of interstellar space, combined with the unique radiation environment outside our solar system's protective bubble, could create conditions where quantum effects become magnified. It's like seeing quantum mechanics with the naked eye, she explained in a classified briefing, something we previously thought impossible. Could this discovery challenge everything we thought we knew about space? Absolutely. If confirmed, it would represent the first observational evidence for quantum gravity, the holy grail of theoretical physics that would unite Einstein's general relativity with quantum mechanics. These two pillars of modern physics have resisted unification for nearly a century, with many physicists considering it the greatest unsolved problem in physics. But there's another, more radical possibility. What if the structure isn't natural at all? Here's where things get truly bizarre. When the quantum AI analyzed the geometric pattern's movements over time, it found something that shouldn't be possible. The pattern appears to adjust its structure in response to Voyager's sensor scans. When Voyager's instruments are actively scanning, the pattern exhibits subtle geometric changes that correlate directly with the scanning frequency and intensity. When the instruments are dormant, the pattern returns to its baseline configuration. This responsive behavior continues across multiple observation cycles, defying random probability. Dr. Jason Chun, an astrobiologist consulted on the project, didn't mince words. It's as though it knows it's being observed. This behavior is reminiscent of the observer effect in quantum physics, where the act of measurement affects the system being measured. But again, this is happening at scales far larger than where quantum effects should dominate. The observer effect is typically confined to subatomic particles, not structures potentially kilometers in size. Further analysis revealed another troubling detail. The pattern began appearing in Voyager's data precisely as the spacecraft passed the helipause, the boundary between our solar system and interstellar space. It's as if Voyager triggered something when it crossed this cosmic threshold. Some scientists on the project have suggested that the helipause might be more than just the boundary of our sun's influence. It could be a delineation between regions of space with different physical properties. Perhaps the laws of physics themselves differ slightly in truly interstellar space, allowing phenomena that would be impossible within our solar system. Others point to the timing as evidence of something more deliberate. The coincidence is too perfect, noted Dr. Samantha Rodriguez, a quantum physicist working on the data analysis. It's like setting off an alarm when crossing a border. But what comes next changes everything. Take a moment to consider what we're discussing here. A human-made object, designed in the disco era, is now so far from Earth that radio signals traveling at the speed of light take over 21 hours to reach it. This lonely ambassador carries golden records with whale songs, Chuck Berry, and greetings in 55 languages. And now this ancient explorer has potentially discovered something that could rewrite physics textbooks or possibly hint at something even more profound about the nature of our universe and our place within it. The distances involved are almost incomprehensible. If the Sun were the size of a grain of sand, Voyager 1 would now be about 4 meters away from it, and our nearest stellar neighbor, Proxima Centauri, would still be 100 meters distant. Voyager operates in a realm of space that humans have never physically explored, a realm we've only glimpsed through telescopes and mathematical models. If you've made it this far, you're clearly into the deep stuff. Hit like and let us know your theory in the comments. Quantum phenomena, higher dimensions, or something else. Your insights might spark the next breakthrough in understanding this mystery. Before we continue to the most mind-bending possibilities, I want to acknowledge that what we're discussing remains, for now, an unconfirmed discovery. NASA has neither officially confirmed nor denied these findings, stating only that analysis of historical Voyager data is ongoing. But multiple sources within the quantum physics community have verified the basic outlines of what we're sharing today. Several peer-reviewed papers have been submitted to major astrophysics journals with publication pending the completion of verification protocols. Let's explore an even more speculative interpretation of this discovery, one that's gaining traction among theoretical physicists studying the data. What if what we're seeing isn't quantum foam at all, but evidence of higher dimensions intersecting with our own three-dimensional space? According to string theory and M theory, our universe may contain up to 11 dimensions, most of which are compactified or curled up so tightly that we can't perceive them. But interstellar space, free from the electromagnetic noise of our solar system, might be precisely where evidence of these dimensions could become detectable. The lattice-like structure could represent what mathematicians call a shadow of higher dimensional geometry projected into our 3D space. Imagine how a 3D object casts a 2D shadow on a wall. Complex information is flattened but still preserves some of the original structure. Similarly, what Voyager may be detecting could be the shadow of objects or structures existing in dimensions beyond our perception. Dr. Mito Takahashi, a string theorist at Caltech who has reviewed the data, describes it as potentially the first empirical evidence for the existence of higher dimensions, something string theorists have been seeking for decades. If so, Voyager may first have inadvertently captured the first direct evidence of these hidden dimensions, transforming string theory from a beautiful but untested mathematical construct into a theory with observational support. Dr. Sarah Matt, a theoretical physicist at Cambridge, suggests another possibility. What if the structure represents some kind of boundary or membrane between different regions of space with different physical properties? This concept, reminiscent of the domain walls predicted in some cosmological models, could explain why the structure appeared specifically as Voyager crossed the helipause. These domain walls might separate regions of space that underwent different symmetry-breaking patterns during the early universe, essentially creating bubbles with slightly different physical constants or even different laws of physics. The implications would be profound. Our understanding of physics as universal and unchanging might need revision. The physical laws we've discovered might be local phenomena rather than universal truths. Let that sink in. If this is true, it suggests that our universe might be just one bubble in a larger multiverse. Every discovery we've made so far might only be relevant within the confines of our own cosmic neighborhood. That means space and time might not behave the same way in other regions. The very fabric of reality itself could be more fluid, more complex, and more dynamic than we ever dreamed. Could we be on the verge of discovering that our understanding of the universe is hopelessly incomplete, even wrong? The implications of this discovery, should it be confirmed, would not only redefine our understanding of the cosmos but also open up a new chapter in the exploration of space, quantum mechanics, and perhaps even the nature of existence itself. If what Voyager 1 has stumbled upon is indeed a higher dimensional structure or some kind of boundary between different regions of space with different physical laws, the ramifications would be immense. Imagine a universe far more complex and layered than we ever thought possible, where the very laws of physics that govern us might not apply everywhere. This idea would bring an entirely new meaning to the word multiverse, suggesting that different bubbles of space could host distinct sets of physical rules, perhaps giving rise to different forms of matter, different types of gravity, or even entirely new kinds of life, completely outside our current understanding. Some scientists have speculated that the discovery could also be evidence of what's called brain cosmology, a part of string theory that proposes our universe could be a 3D brain, short for membrane, floating in a higher dimensional space. According to this theory, our universe could be one of many brains, each with its own set of dimensions, existing in a higher dimensional multiverse. If Voyager 1 has detected some sort of connection between our universe and another brain, it could be a literal doorway or bridge between our reality and another, a kind of interdimensional threshold. It's a tantalizing idea, one that would take physics into a realm of science fiction but with a real possibility based on theoretical foundations. Another possible explanation for this strange phenomenon involves a concept called dark matter and dark energy. Although we can't directly observe dark matter or dark energy, we know they make up the vast majority of the mass and energy content in the universe, and they seem to interact with normal matter in ways we don't yet fully understand. Could Voyager 1's encounter with this structure be related to some unknown aspect of dark matter or dark energy? There are theories that dark matter might have exotic properties, and perhaps what Voyager has detected is an interaction between our solar system's known matter and this mysterious substance from the deep recesses of space. This could help explain why this phenomenon is appearing as a pattern or lattice structure, possibly the manifestation of an unknown force that only reveals itself in interstellar space. One intriguing hypothesis suggested by several theoretical physicists is that this anomaly could also be the result of advanced extraterrestrial technology. Although this idea may seem far-fetched to some, it cannot be ruled out entirely. Could Voyager 1 have encountered a relic of an ancient, alien civilization that once traveled the stars? Perhaps the structure detected is a piece of technology, something akin to a vast cosmic sensor network, or a long-forgotten machine left behind by an advanced species that used this technology for interstellar communication or exploration. The pattern of movement, the changes in response to Voyager scans, and the strange geometric nature of the structure could all suggest something artificial. Some theorists speculate that extraterrestrial civilizations might have mastered the manipulation of quantum and spacetime phenomena in ways that humans can only dream of. As exciting and mind-bending as these possibilities are, it's important to remember that the data is still being analyzed. NASA has yet to officially comment on whether this discovery will lead to a shift in our understanding of space and physics. Much more work will be needed to fully investigate the anomaly, gather additional evidence, and rule out alternative explanations. And, of course, we have to be cautious about jumping to conclusions too quickly. Space is a vast and mysterious place, and sometimes what we think is a revolutionary discovery might turn out to be an illusion or misunderstanding. However, the very fact that this discovery is even being discussed is a testament to how far our understanding of the universe has come. It wasn't long ago that the idea of exploring interstellar space seemed like science fiction. Now, Voyager 1, a spacecraft built with 1970s technology, is sending back data that could help us unravel the mysteries of the cosmos. If it turns out that this anomaly is indeed a legitimate scientific breakthrough, it could signal the beginning of a new era in space exploration, one where the most mind-boggling questions about the universe are no longer confined to the realm of science fiction. This is an exciting time for scientists and space enthusiasts alike. The future of space exploration looks brighter than ever, and who knows, perhaps the next great breakthrough in our understanding of the universe is just around the corner. One thing is certain: the mysteries of space are far from being solved, and as long as we continue to push the boundaries of exploration, we're sure to make even more discoveries that will challenge everything we think we know. The future is uncertain, And the questions raised by this new anomaly could lead to an entire paradigm shift in our understanding of the universe. Whether it's the discovery of higher dimensions, the detection of an unknown form of matter, or the discovery of extraterrestrial intelligence, the implications of Voyager 1's findings could set humanity on an entirely new course. And as we move forward into the great unknown, one thing is clear. We've only just begun to scratch the surface of the mysteries that lie beyond our planet. Stay tuned, as the next few months and years could bring the answers to these profound questions, and possibly even more mind-bending revelations that challenge the very fabric of our understanding. As we continue to explore the depths of the cosmos, the potential discoveries that could emerge from Voyager 1's data may ignite entire new fields of research. While we're used to thinking about space as something vast and empty, this anomaly challenges that perception. It suggests that space might be filled with hidden structures and complex phenomena, some of which may exist in ways that are entirely alien to our understanding of physics. If this detection is part of a larger cosmic framework, we might be looking at a future where new, exotic laws of physics emerge. In the coming years, as scientists continue to examine Voyager 1's findings, there could be a shift toward developing new theoretical models that incorporate higher dimensional spaces or undiscovered interactions between matter and energy. If this anomaly proves to be tied to a higher dimensional or quantum mechanical effect, physicists might need to create entirely new mathematical frameworks to describe these forces and their impact on our universe. It could be the next step in humanity's quest for a unified theory, a theory that ties together gravity, quantum mechanics, and other fundamental forces in a way we've only dreamed of until now. Perhaps more thrillingly, this discovery might reignite debates and investigations into other phenomena that have long been unexplained, such as the mysterious nature of dark matter and dark energy. Could the anomaly detected by Voyager 1 be the first real evidence of dark matter interacting with our known universe in a detectable, observable way? Up until now, dark matter has remained elusive, detected only indirectly through its gravitational effects on visible matter. But if Voyager 1 has encountered a structure influenced by dark matter or even dark energy, it would fundamentally change the way we think about these unseen forces. We could be standing on the cusp of uncovering one of the universe's most profound and elusive mysteries. There's also the tantalizing possibility that we might be dealing with a form of quantum foam, a term used in quantum mechanics to describe the microscopic fluctuations that occur in the fabric of spacetime at the Planck scale. The idea that spacetime itself might have a texture on the smallest scales, with quantum fluctuations that could create temporary bubbles or regions with different physical properties, could explain the kind of irregularities Voyager 1 might be detecting. These bubbles could be manifestations of a deeper level of reality, hidden beneath the calm surface of what we consider to be our stable universe. This could mean that, even in the emptiest reaches of space, there is a dynamic and chaotic underlying structure, a quantum web that influences how galaxies form, evolve, and interact. Looking at the long-term implications, this discovery could have practical effects on how we design future space missions. If Voyager 1's detection is linked to some new type of cosmic structure or phenomenon, future missions may need to be equipped with new tools and technologies capable of measuring these properties. Instruments could be developed to detect the subtle signatures of higher dimensional interactions or even the presence of exotic matter that could be invisible to current technology. As we develop new spacecraft, we could also explore deeper into interstellar space, searching for other anomalies or breakthroughs in understanding that could dramatically change our technological trajectory. Moreover, if the anomaly is confirmed to be something that challenges our basic understanding of spacetime and the laws of physics, it could inspire a new generation of scientists and engineers to tackle problems and questions that were once considered too speculative. Just as the discovery of electromagnetism led to an era of technological revolution, a breakthrough of this magnitude could give rise to innovations we can't yet fully imagine, perhaps even opening the door to new forms of energy, propulsion, or communication. In the context of human civilization, this discovery might have profound philosophical and existential implications. If we truly find that there are structures or forces in space that transcend our current comprehension, it could forever change how we view ourselves and our place in the universe. The possibility that other civilizations, perhaps far older and more advanced than ours, have left markers or technologies scattered throughout space could challenge the fundamental assumptions we hold about our uniqueness. It would invite us to look beyond our borders and think about the wider cosmos, not just in terms of physical exploration, but as a grand, interconnected system of intelligence and phenomena. At the same time, it's important to stay grounded. The excitement surrounding Voyager 1's discovery is understandable, but the scientific community will need to exercise caution and skepticism as it analyzes the data. The universe is vast, and strange phenomena are often the result of new physical processes or previously unknown effects. As we continue to sift through the data and use more sophisticated tools to gather information, the mystery will unfold. Slowly, carefully, and with the rigor that the scientific method demands. But if this anomaly turns out to be the real deal, the world of science will be on the verge of a new, exciting chapter in the history of space exploration. For now, we wait and wonder. Voyager 1, our intrepid ambassador to the stars, continues its journey, carrying with it the hopes of humanity to answer some of the deepest questions we've ever asked. It's a reminder of the incredible legacy of human curiosity and our drive to explore the unknown, and it shows that even in the farthest reaches of space, we are still learning, still discovering, and still reaching for the stars.